is Naveena from the Department of Cyber Security in the Institute of Aeronautical and Engineering, Dundigal. And in my previous videos, I have discussed by means of a network layer, we should be playing a vital role under the OSI reference model. And meanwhile, that network layer is present in between the data link layer and the transport layer and the physical layer. It is present in between the transport layer as well as the data link layer. So, and up to now, according to my previous videos, and I have discussed with you by means of a network layer design issues as well as and what are the applications of a network layer, what are the services which should be provided by means of a network layer, and what are the services utilized by means of a network layer, and what are the routing algorithms, and what are the protocols, and what is the type of calculating the routing of a packets, the cost and the least cost path by means of a routing algorithms like distance vector algorithm, as well as the link state route algorithm, as well as the congestion controlling algorithms, like what are the types of congestion control algorithms which should be determined under the network layer. So by this video, and I want to discuss based on that the QoS, what I mean to say QoS, quality of service in network layer, and the Qos concepts like congestion management as well as the queue management, and the link efficiency, elimination of overhead bits, traffic shaping and policing, and the QoS terms in networking, as well as the improving the techniques for the sake of QoS in networking, and like mobile QoS and network QoS, and some examples of the internet working in the network layer and why the QoS is important in networking, and the three types of QoS like application QoS, IP QoS and role QoS, and the exemplary of QoS, quality of service in network layer, as well as the various type of traffics which should be included under the QoS measures, and why the QoS is important while you are dealing with the network layer. So coming to this, and what do we mean by QoS? Why QoS is important in networking? So coming to this one, the QoS, if you can define, it is nothing but the quality of service. The quality of service which should be provided by means of a network layer. So coming to this, the quality of service, and if you can determine or if you can define the quality of service determines a network capability to support predictable service over various technologies containing the frame relay, asynchronous transfer mode, that means ATM, and the Ethernet, the SONET, and the IP routed networks. The networks, these type of networks can use any or all of these frameworks. And secondly, if you want to define the QoS also provides that while supporting priority where one or more flows does not create other flows fails. A flow can be combination of the sending of the packets by a selected path from one source to the another destination addresses, and source and destination must would be having the addresses ID, that means the packet addresses, the ID and the socket numbers, and a part of that the session identifier or packet from a specific application or an incoming interface. And thirdly, the QoS is primarily used to control all the resources like the bandwidth by means of a networking and the equipment, the wide area facilities, etc. It can get more efficient use of network resources which will be provided by tailored services provide coexistence of mission critical applications, etc. And these are the 3 points what I mean to say. The first one is the definition, which is useful to determine the network capability to support predictable service over various technologies. That means network's capability means to check the network on what network that the data packets can able to transfer from one node to the another node, or from one sender to the another receiver. And after that one, these are the 2 types of services which should be provided by means of a QoS while we are working with network layer. So coming to this, the second concept what I want to explain, Qos concepts. The Qos concepts are explained below. The first one is the congestion management, second one is the queue management. And the first one is the congestion management. In this, the bursty future of data traffic sometimes bounds to increase traffic more than out of that connection speed. QoS allows a router to put packets into different queues. Specific service queues more often depend on priority than buffer traffic in an individual queue, and let the first packet by the first packet out. Here also, like the queue only, first in, first out, which you have already seen mentioned by means of a congestion management. Let the first packet by the first packet out, first packet in and first packet out. This is called the congestion management. What I mean to explain, the burst future of data traffic sometimes bounds to increase traffic more than a connection speed. So this is one of the QoS concepts. And second one is the queue management. The queues in a buffer can fill and overflow. A packet would be dropped if a queue was complete, and the router cannot prevent it from being dropped if it is a higher priority packet. This is referred to as a tail drop. That means whenever the packets they are able to sending or ready to sending or about to transmit from one source to the another destination, and the queues in a buffer can fill and overflow. So here all these packets they are able to transmit or about to transmit from one sender to the another receiver, or from one source to the another destination here. So whenever at the point of a destination it will be filled, all of it can be filled by means of a packets overflow. Packet overflow. So a packet would be dropped if a queue is complete, and the router cannot prevent it from being dropped if it is having a higher priority packet. This is nothing but the queue management. And coming to this, the third one is the link efficiency. The low speed links are bottlenecks for lower packets. That means the serialization delay caused by the high packets forces then the lower packets to wait no longer. The serialization delay is the time created to put a packet on the connection. So this is this point of concept, what we can call it as the link efficiency. And coming to this, the time the serialization delay must be calculated by means of the 2 types of terms, what we can call it as a elimination of overhead bits as well as the traffic shaping and policing. Elimination of overhead bits means it can also increase efficiency by removing too many overhead bits. That means one source to the one destination, this path consisting the flow limit. That means 10 number of packets needs to transmit from one source to the another destination, or n number of packets can needs to send or travel from one source to the another destination. If it would be exceeded, if it would be overflowed, that point what we can call it as a overheaded bits. And after that one, traffic shaping and policing. Shaping can prevent the overflow problem in buffers by limiting the full bandwidth potential of the application packet. Sometimes what was happen, many networks topologies with a high bandwidth link connected by means of a low bandwidth link, and in the sides can overflow low bandwidth connections. Therefore, the shaping is used to provide the traffic flow from the high band link to the closer to the low bandwidth link to avoid the low bandwidth links overflow. And policing means it can discard the traffic that exceeds the configured rate. Configured rate means every path must having a need to flow the transmission of the packets or traveling of the packets under the bits per second. If it exceeds that point, what we can call it as a configured rate, but it is buffered in the case of shaping and policing. But it is buffered in the case of shaping and policing. So, after that one, let us understand how the concept of quality of service in networking should be involved. If you can think QoS in terms of networking, that means QoS in the case of networking implies the ability of a network to provide reliable service to the traffic over various technologies, which should be included by means of Ethernet, wireless or IP or asynchronous transfer mode like ATM, etc. Asynchronous transfer mode, ATM, etc. That means if in case of network congestion, this QoS has to keep in record various elements which will be causing the congestion. It may be due to the reason of low bandwidth or high traffic on a single route. High traffic on a one single route. That means if you can take the high traffic or heavy flow, if you can able to determine by this only from one node to the another node. High traffic on a single route. So, routing protocol being used heavily impacts the quality of service of networking in the network layer. So, it depends on how efficient a routing algorithm is to detect the traffic on a particular path, which should be mentioned by means of some of the packets, those who can able to decided to travel from one source to the another destination and to choose a route accordingly to prevent network congestion on a particular route. So coming to this, and next, the concept is improve QoS in networking, and how the quality of services, what are the application of the quality of services already, and I have explained now, and how the improving QoS in networking, and what are the steps we should be taken to improve the quality of service in networking. It is explained below as how we can able to improve the quality of service in networking under the network layer. So the first one is the quality of the service of the network in the networking layer can only be improved by reducing the network failures and reducing the congestion. The first point is network failure, second one is the reducing the congestion. For this, the company has to analyze the underlying hardware like switches, the routers, hubs, etc. and the underlying software such as routing algorithms to improve the QoS. And this is the third technique which can able to determine or able to explore to improve the QoS in the networking means the routing algorithms which should be determined or created or developed to improve the QoS. And the third one is the routing algorithm should be intelligent enough to select the best possible route to transfer a packet from its source to the destination by keeping in record of various networking factors such as what are the networking factors here we need to consider to improve the quality of QoS in networking means such as latency rate, network congestion, traffic on a particular route and bandwidth of the network. That means latency rate, network congestion means if you can take one path that packets are ready to transmit from one source to the another destination. Some of these factors we need to consider to improve the QoS in networking like latency rate. That means the rate of flow of packets from one source to the another destination, what we can call it as a bits per second. And latency rate means if 5 packets can able to transmit in the middle, if any packet will be discarded, this will be the discarded packet or disrupted. So only the 4 packets can able to transmitted from one source to the another destination. These 4 packets out of 5 packets, the rate of transmission of the discarded packets in the middle and the remaining packets can able to flow from one source to the another destination. That rate of flow of packets, what we can call it as a latency rate. So next one is the network congestion. Network congestion means whenever a bulk of packets, they are able to move, they are ready to move from selected path by means of a one sender to the another receiver or from one source to the another destination. If all the packets they are able to move, and as I have already explained in my previous videos, and every packet should be determined by means of a network addresses and according to the routing table determined by means of a one routers or routing algorithm. So here the bulk of or the n number of packets, they might be ready to transfer or to travel from one sender to the another receiver. So the other part of the second node or the destination parts will take care of acknowledge those packets and sending those acknowledgements to the concerned sender. If that destination did not get that acknowledgement of the packets, those who are already in the traveling from one sender, that might be denoted or implies or determine some of the heavy flow or the congestion will be occurring in the middle of while transferring or transmits the data packets from one source to the another destination. That means a part of the limit of the packets which will be travel or sending from one source to the another destination, and there should be some heavy flow or exceeded of the flow of the packets we might be observed. That condition what we can call it as a network congestion. And according to the situation, the destination part did not get the acknowledgement as well as parallelly whenever it did not receive that acknowledgements and it did not send it those type of acknowledgement whatever the packets he received to the concerned sender, and the concerned sender is in waiting mode, keep on quiet and waiting mode, and these many type of packets I have already sent it, but this node 1 or sender 1 can have a need to wait how many packets she sent it, and this will not be getting back by means of a concerned acknowledgement. That is called the network congestion. Based on the traffic on a particular route, traffic on a particular route means if some of the packets or if one packet or 2 packets can determine to go by a one physical path from one node to the another node, and if it will be any congestion control or any heavy control or any error control will be occurred while traveling the packets from one node to the another node, those packets will be discarded. Those packets will be identified and discarded. So what was happened by this act, the traffic will be jammed and the other packets may not have any to reach the successive destination. So what was happened, these packets, whenever there is a second path or any third path it will be there, these packets will be routed automatically to the second path which should be already designed or developed to reach their successive destination. That means selection of a packets other than the discarded packets to reach their successive destination, that position, that condition, what we can call it as a traffic on a particular route. And bandwidth means there should be a flow of this type of number of packets or n number of packets, or this type of number of packets might be need to transmit or might need to send from one node to the another node. That number of packets needs to travel from one node to the another node. That condition what we can call it as a bits per second. That condition what we can call it as a bandwidth. And coming to that, improve QoS for a network based application, and we can improve the QoS again, and we have already seen the some of the techniques and the factors which are useful to improve the QoS in a internet networking of a network layer. Here, improve QoS for a network based application, and what are the first condition means we can improve the QoS for a network based application with the help of the following factors. What are those factors? Use protocols to know the best way to implement a network based application. Use protocols to know the best way to implement a network based application. Next one, use the best and intelligent routing algorithms. Always try to create the functionality to different layers of the network. The first one is to improve the QoS. The first condition is the protocols, and second one is the routing algorithms. So these are the main two essential applications which are useful or designed to improve the QoS, quality of service, for a network based applications in networking layer. What are those two factors? The first one is the use protocols to know the best way to implement a network based application, as well as use the best and intelligent routing algorithm to different layers of the network based on their functionality. So coming to this, the next applications are the mobile QoS and network QoS. Here we have to identify, up to now we have already defined and learned what are the applications of the QoS and how far it will be played a role in the network layer, or what are the types of QoS, what are the services provided by the QoS. So hence, these are the two types of QoS. What are the two types of QoS? Mobile QoS as well as and the network QoS. Mobile QoS and networking QoS. So here, what I mean by the mobile QoS means it refers to the mobile quality of service. That means in this mechanism, in mobile control, the reliability, usability and performance of a telecommunication services we might be seeing. So coming to this, the second part of a QoS is nothing but the network QoS, which can refers to the network quality of service. QoS mechanism, or in this mechanism we have to identify the network manages the traffic of data to minimize the loss of packets, error control, heavy control, as well as the jitter and the latency on network. And thirdly, what are the metrics we can use to improve the quality of service or QoS in network layer. So out of this, the third factor is nothing but the matrix. This matrix that determine the QoS in mobile or the coverage, the accessibility, including GOS and the audio quality. What are those conditions? The coverage, accessibility, including GOS and the audio quality. So here, those are the above metrics which shall determine the QoS in a network or under the network traffic effectiveness and network bandwidth, mainly by means of network effectiveness, network traffic effectiveness as well as the network bandwidth. So coming to this, what do you mean by internet working in the network layer? According to the internet working, what do you mean by internet working? This is the main role of the network layer, main role or the main part of the network layer which can provides a logical connection between different types of networks. Like if you can take one example according to our college, that lab consisting of many systems, the system 1 and system 2, system 3, system 4, system 5, system 6, and each should be interconnected by means of some logical connections, what we can call it as a LANs, LAN network between different types of systems. We can able to connect those type of systems by means of internet working under the networks layer of one internet working. We have to identify this is the main role of the network layer, which can provide a logical connection in between the different types of systems by means of different types of networking under the network layer. This is the main concepts of internet working, and this is the one of the example I have already explained based on that our college. Suppose if you can take all the systems we shall be connected by means of a local area network LANs through different types of users under one network, under one subnet of networks. And second one is the internet working is the technique of interconnecting the different types of networks together, this one, and using connecting devices in between them, what we can call it as a routers and gateways, routers and the gateways. The different types of networks are owned by different entities which are widely used, varying in terms of network technologies. These networks may be public, private, government, business or academic or in nature, which may be varying by means of the different sizes from LANs to a large WANs, which may be vary according to the sizes from LANs to a WANs. So, the resulting network of networks is generally termed as internet work or simply internet. That means internet work means, and what I want interconnecting the different nets together, the technique of interconnecting of different networks together, interconnecting of different networks together, what we can call it as a internet working. So nowadays the people and the social media, the mobiles and the laptops, the social media, it will be running fastly, means by means of the very speed range of internet we should be available in the society and useful by means of a people in and around by means of the society. So coming to that one, to enable an efficient data communication among multiple networks, the connected networks decide upon a common protocol stack or communication methodologies. What are the two type of communication methodologies which are meant to define the protocols which are meant for the communications are the two architectural models which are designed to define the protocols used for the communication are the open system interconnections model, what we can call it as a OSI model, the first one. Second one is TCP/IP model. TCP/IP model, that means transmission control protocol. And internet protocol. So here these are the two type of architectural models which are designed to communication purpose. What we can call it is, the first one is the OSI reference model as well as the TCP/IP model or the internet protocol suite. The other name for the TCP/IP model is internet protocol suite. And coming to this, the examples of the internet working up to now we have already seen based on the services of a QoS with many examples, applications of the QoS and in the network layer, and how, what do you mean by internet working and how it will applicable with different types of networks in networking. And this is the examples of the internet working. Here, the most widely used internet in the internet applications or capitalization implies one specific internet that uses the TCP/IP suite for interconnections, means it is the biggest services in the World Wide Web. One of the examples of the internet working is World Wide Web, as well as the modern internet is present from came in the early of 1990s. Since then, it has been growing and it is presently used by a few billion of people all over the world, in and around the world. And the third point is the predecessor of a internet was the ARPANET, that was developed in the late ages of 1960s and early of 1970s, which should be developed, the ARPANET recognized and developed in the late of 1960s as well as in the early of 1970s. It was a packet switched networks which was developed protocols for internet working. So again, and one of the applications of the internet working is, nowadays it is the biggest service for the World Wide Web, and since it has been growing and it is presently used by many multiple billions of people throughout the world. And coming to this one, the next one is why QoS is important in networking. Up to now, we have already seen the QoS and the applications of the QoS and the services provided by the QoS. So here, why the QoS is important in networking? Designed to reduce interface or interference such as the factors packet loss, jitter, the latency. QoS oversees network resources control and the management. Here, the QoS also sets the boundaries and priorities for different data categories which can travel between the IP networks as the bandwidth traffic across the network technology. And here, our network system or the network layer supports three types of QoS. What are the three types of QoS? Application QoS, IP QoS and role QoS. Coming to this, the first type of system support QoS, the first one is the application QoS. In this, which can controls the bandwidth used by the applications. And second one is the IP QoS, which can controls the bandwidth of design by means of IP addresses. So coming to this, the role QoS, also called as role-based QoS. The role QoS, also called as the role-based QoS, which can controls the bandwidth of designated roles. Mainly, these are the three type of system supported QoSs. What we can call it as application QoS, IP QoS and role QoS. After that one, and this is one of the exemplary pictorial diagram which could be representing the quality of services in network layer, like so data, voice of the data router 1, here router 2, and which can be connected by means of through different networks, what we can call it as a switched networks. And here if you can identify, this is the switch network 1, this is the switch network 2. Out of this one, this will be the router will be connected, the router 1 will be connected, the router 2 will be connected with some capacity of some network 01, and here, and system outputs, these are the system outputs. Here the data will be transmitted by means of signals from one router to the another router. After that one, whatever the type of network we have already connected to this router, suppose if you can take exemplary, if you can define this by means of a geo or IDR routers, it will be connected to the switched networks of 2, and already switched network of 1 will be there. This router, it will be connected again to the SW1 switched network of 1. Here the switch network of 2. After that one, it is connected to our system, host system. This is to our personal PC, and here the SWT is connected to our host personal system of 2. Host personal system of 2. This is host system of 1, and already it will be connected to a modem by means of a telecommunication system. Here, if you can identify, whenever a signal, it will be the data will be transmitted by means of a voice signals from one router to the another router, which should be linked by means of another switched networks here. And a part of this one, the router 1 will be connected with the S11, what we can call it as a switched networks 1, by means of a host, what we can call it as a personal system. And here SWT is by means of a host which will be connected by means of a system 2. Again, from this personal laptop or our personal PC, the signals it will be coming again. Whenever it will receives, it will converts it and retransmits it to the connection whatever we have already developed or given. This is one of the examples of a quality of service in network layer. That is what we can define means this is one of the process of how the data will be going from one router to the another router, and it will be transmitted to the switched networks, what we can call it as a many networks, which will be linked together to our PC by means of a telecommunication modem used devices. Coming to this is one of the representation of the various types of traffic that QoS measures. QoS means quality of service in network layer measures means the first one is the bandwidth, second one is the delay, third one is the loss, fourth one is the jitter. What do you mean by bandwidth means the number of packets which are defined on a particular path or a logical connection which should be established from one source to the another destination. That means bits per second. That rate of flow of the data packets from one node to the another node, what we can call it as a bandwidth. Delay means, and if there is any heavy control or error control must be identified, there should be a delay of traveling the packets or sending the packets from one node to the another node based on the error owned or any congestion control, heavy flow or any disturbance, it will be occurred in the middle of the path while sending the data packets from one source node to the another destination. That's the condition what we can call it as a delay. Loss means if sender has a need of sending the n number of packets or 10 number of packets. So in the middle, if there is any error, it will be occurred or any packet will be discarded by any factor. So that condition what we can call it as a loss of packet. That packet will be replaced immediately in the middle discarded, and another packet will be another packet will be replaced, and the other number of packets can able to travel in the same path from one node to the another node. Jitter means here, if you can see that how many number of packets a one node or a sender have a need to send it, that type of number of packets to the destination may be received or not. That's the count of number of packets while sending, that the number of packets which will be after the traveling or reaching by means of a destination should be the same. That means the sending point of packets at the node 1 and the sending number of packets at the node 1 and at the destination side the packets it will be received at node 2 received, and here sender should be the same. That condition what we can call it as a jitter. So the various types of topics by means of a QoS measures are again bandwidth, delay, loss and the jitter. So again, why the QoS is important. Today, all the data networks are converging by means of a whether switch type of networks and LANs, WANs and the MANs. MANs are converging on IP transport because an application have migrated towards being the IP based network. Hence, the converged network mixes different types of traffics and with which entirely different type of requirement. So, hence, if we can define the QoS technologies plays a crucial role in a multi-service IP network environment. In multi-service IP network environment. And here again, I want to discuss, as I already explained, all the concepts with related to the quality of service again, and I hope by the end of this video it will be useful by means of the concept what a student can able to learn means mainly the applications of the quality of service. What do you mean by a QoS? Why it is so important in nowadays? And what are the QoS concepts like congestion management as well as the queue management as well as the link efficiency and how to eliminate the overhead bits and how the second condition is the traffic shaping and policing again and how the terms of a QoS in the networking by means of a network layer and again how what are the factors we should be influenced to improve the QoS in networking, like the avoid the network failures as well as the reducing the congestion and by means of developing the type of routing algorithms to improve the QoS and some of the networking factors we should be keep in record while you are developing the while you are working with quality of service in network layer like the latency rate, network congestion as well as the traffic on a particular route and the bandwidth on a particular network. Again, and what are the two types of factors which are included to improve the QoS for a network based applications like the protocols and the routing algorithms as well as what are the two types of QoS applications, mainly the mobile QoS as well as the network QoS and the metrics. That means what are the metrics or the factors if you are working with QoS in the network layer like the coverage accessibility including the GOS and the audio quality, the high level of audio quality and the other metrics like network traffic effectiveness as well as the network bandwidth and how the internet working is interconnected with the QoS. It is nothing but the interconnecting of many devices with a switch type of networks and what are the types of internet working like LANs and large WANs and what are the two architectural models which should be defined which are useful for different communications are the OSI reference model as well as the TCP IP or and that means transmission control protocol as well as the internet protocol and in another way and if you give the name of a TCP IP model, if you can define the TCP IP model, the other name for the TCP IP model is nothing but internet protocol suite as well as the examples of the internet working like World Wide Web nowadays, ARPANET which would be the base pillar to develop the internet working and Google search, World Wide Web and MSN, Hotmail. So many services you should be used and utilized by billions of people all over the world. And why the QoS is important means it is also not only in the domain sector by means of a international overseas network resources and controls all the capabilities and management a part of IP networks as the factors bandwidth traffic across the networks and what are the three types of QoS which should be supported by means of a network system like application QoS, IP QoS and the role based QoS by means of a example how the voice signals it will be transmitted or travel from one system to the from one network to the another network, from one router to the another router through our concerned host, and what are the various type of traffics that QoS measures like bandwidth, delay, loss, and the jitter. So I hope this video should be useful to the students. Thank you for watching and keep watching upcoming video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.